Hi guys, today we are going to solve the longest element in an array. Here the given array is 4, 9, 5, 7, 15, 5. So to solve a problem we have different approaches. Let us see the brute force solution for this question. So first here the elements are in the array which are not in sorted order. So let's first sort them. Here we are going to apply any one of the sorting methods like merge sort, quick sort, so that it will take the complexity of n log n. So for sorting we are going to take n log n time complexity of n log n time complexity. So here after sorting it will be 4, 5, 7. So we are having 2 5s, so here we are going to write 2 5s, 7, then 9, then 15. So after sorting we can see that our n minus 1th element. So here we are having how many elements? 0, 1, 2, 3, 4, 5. So we are having 6 elements, in which the 5th element, the index which having the 5, it is our longest element in the array. So we can directly return the array of n minus 1 element. This is the basic solution which we can think of. Then let us go with the optimal solution. So for the optimal solution, so here our brute force solution is taking O of n log n time complexity. So we need here the space complexity is nothing but O of 1. So here we are taking more time. So to decrease the time complexity, here it is taking n log n. So we need to think of the solution which takes like log O of n time complexity. So here the elements we need to traverse through the array at least only for once, so that we can get the solution of the largest element. So here first let's take 4 as our, let us take a largest element as 4. So here we are taking 4 as the largest element. So next we are going to go to the next at I is equals to 1. When I is equals to 1, the element at a of I is 9, which is greater than 4. So we need to remove this and we need to change it to 9. So again we have to see the next element. What is our next element? It is 5. So 5 is not greater than 9, so we cannot change it. So 9 will be there in our largest element. It will be 9 only. So the next element is 7. Is 7 is greater than 9? No, it is not greater. So we will not change it. Is 15 is greater than 9? Yes, 15 is greater than 9. So we will change it to 15. Is 5 is greater than 15? No, 5 is not greater than 15. So our largest element is 15, which we got only by traversing through the array only for once. So here let us see the code. I will be writing code in Java, or you can take it as like normally you can take it as pseudocode. So here let us take the largest element, int largest element as array of 0, which means we are storing here the first the 0th index element in the largest. So we need to traverse through, from 1 we have to traverse through the up to the length of the array. So we are taking int I is equals to 1 till where we have to traverse, till the array length. Should not consider array length, because array length is 6. Here we have until 5 only. So up to array dot length I plus plus. Here what is our condition when we are taking the element which is largest, which is the greater than largest, which should be greater than our largest element, then we need to change it. So here it will be the condition like if array of I, which here the element which we are taking in the array or array of I, it should be greater than the largest largest element, the element which is present in the largest. So we will change it. So we need to change the largest to that array of I or the element which we are taking. So here array of I, if it is greater than largest, we will change it our largest. Initially we took as array of 0, but array of 0 is not greater than 9. So we need to change the largest to 9. We need to change it to array of I because this is greater than, this is not, this is less, this is greater. So we need to change it. Here you can directly return the largest. Okay, this is our first question. It is an optimal solution. Here we are taking from, here we are, the for loop is running only for once through the array. So we are taking the time complexity. Here I will be writing as TC. Time complexity is O of n. Space complexity is O of 1. Here n denotes the number of elements present in the array. Now let us go to the next solution as second largest element in an array. To find the second largest element, don't think like after sorting we need to take, for largest we are taking n minus 1 element, no? For largest we took n minus 1 element after sorting. Don't think like after sorting we need to take n minus 2 element to get the second largest. We need to think in a way like, for example, let us take this question. We need to sort it. For sorting, how much we are taking time complexity? N log n. So 4, after sorting it will be like 4, 5, 7, 9, 15 and then again 15. So if after sorting, this is our n minus 1th element, this is our n minus 2 element, but is it lesser than, is it looking like second largest element? No, it is also the largest element, it is also the largest element. We need to return the 9. This is our second largest element. So after sorting what we have to do means, we need to traverse from back side. We need to check whether this element is, whether this element is less than 15 or not, or you need to check like whether this element is less than the largest or not. If it is less than the largest, then it is our second largest element, or else it's the largest element itself. So here after sorting we need to take from first way you can understand the largest element as 15. So here we are taking that, in that process only we need to take here the largest element which is n minus 1. So from for loop we need to traverse from n minus 2. There is no need to compare the last element, it's not required. So here this is our largest element. From n minus 2 we need to do till I is greater than or equals to 0. Why we are taking till I is greater than or equals to 0? Because there might be, the array might be containing all the numbers which are same, like it might be having 15, 15, 15. So here there is no our second largest element, so we cannot have here. So while we are traversing we need to check whether the element which we are taking over here, it should be less than the largest. So here if condition will be like array of I, it should be less than largest, so that our second largest will be array of I. After we are getting the first, like if we got here the second largest, we need to break out of this loop. You can write break condition and you can come out, you can return second largest element. So here the time complexity for this solution will be like n O of n log n plus O of n. Why we are taking O of n is, if all the elements over here, all the elements, if all the elements are same, like if all the elements are same, then we need to traverse to all the array. So it might take O of n extra time complexity over here. Here we are not taking any extra space, so the space complexity will be O of 1 only. So next see the better solution. So for better solution, here first we are going to traverse through whole complete array at once, and we are going to find the solution. It's like the same the largest solution, largest element in the array, we need to find the largest element. So after I have explained this, so you can find the largest element. After finding the largest element, what we have to do is, we need to take second largest element. Let us take SL, second largest element as -1. So here just we need to traverse again through the array from the initial to the final, and we need to check like how we have to check means, here after traversing through the array we can get the largest element as 15, which we know. So here after getting 15, what we have to do, we need to completely traverse through the array, and we need to check whether whether our second largest element should be, sorry, here the element should be greater than second largest element, but that element should be less than the largest element, so that it will be the our second largest element. What we have to check, I will explain it again. So here the element which we are taking, it should be greater than second largest element. So here 4 is greater than -1, yes it is greater. We should not take as 4, we need to check whether that this 4 is less than the largest, because we need to find the second largest, not the largest element. So we need to compare with the largest element, it should be less than the largest. Yes, the 4 is greater than the second largest element and it is less than the largest element, so we need to change it to 4. Then we need to go to 9. Whether the 9 is greater than 4, yes it is, 9 is greater than 4 and 9 is also less than 15, so we can change it to 9. Then again we need to check the 15, is 15 is greater than 9, yes 15 is greater than 9, but over here the 15 is not less than the largest element, which is our 15, so we should not change it here. Then again we go to element 7. Here the 7 is greater than 9, no it is not greater than 9, so we should not take it. Then again 15 is greater than 9, yes 15 is greater than 9, but it is not greater than largest, but it is not less than the largest element. Then we need to check the 5 is it greater than 9, no. So here our second largest element is 9, which we have got over here, it is our second largest element. So what we have to do, first we need to take initialize int largest element, I will write as L, int largest element as a of 0. Then we need to do for loop to find the largest element. For loop, how we have to do, int I is equals to 1 to I less than array dot length I plus plus. Here what we have to check, for to finding the largest element, we need to check whether the element which we are taking should be, whether it is greater than our largest element, then we need to change it. So here if condition will be array of I is greater than largest, then largest will be changed because it is becoming the less, so we need to change. Till here we can find the largest element. We got our largest element. Then what we did, we need to traverse to the array and check whether this element is should be greater than the second largest element, but it should greater than the second largest element, and it should be less than the largest element. So we got here largest element, so we need to traverse for loop again from int I is equals to 0 to I less than n I plus plus. Here we will take our second largest element as -1. If we need to check array of I is should be greater than second largest, and array of I should be less than the largest. You can take as less than the largest, or you can take as not equals to largest. You can take anything. Is it fine? It's fine. So the second largest element will be array of I. So over here, when we are traversing for the first for loop, it will be taking O of n time complexity. Let's change our pen. O of n time complexity, and for this it might take, it will also take O of n time complexity. So overall for this our second approach, the time complexity will be O of 2n, and the space complexity will be O of 1. Over here for our second largest element problem, the first solution was taking O of n log n plus O of n. We have optimized to O of 2n. So here in the third solution we are going to optimize it to O of n. Let us see how we are going to optimize it. So here we will take initially as largest element as array of 0 and the small second largest as -1. So we need to travel, we have taken this element, so we will not take this element, we will going to traverse from here. So we are here, we are taking 9. 9 is greater than our largest element. What we have in largest element, we are going to have 4. So is it greater than 4? Yes, it is. 9 is greater than 4. So what we have to do, we need to update this both. Here you can change this to 9 because 9 is greater than our largest element. So 9 can be our largest element. It may be our largest element. So what happens to 4? Before updating this largest to 9, first we need to update our second largest to 4, because we have taken as the largest as 4. So it might, if it is not our largest element, it might be our second largest element. So we need to, before changing this, we need to make the largest second largest as our largest. Here then we can go with the 15. Is 15 is greater than 9? Yes, 15 is greater than 9. Then we need to check, then we need to change the second largest element to our largest element, which is 9, and the largest element to 15. Suppose we are having here 25. Let us take here, it is having 25, so we can use traverse. So again we need to check as 7. Is 7 is greater than 15? No, it is not greater than 15. So we should not change any of this. Then again we need to check, is 7 is greater than 9? No, it is not greater than 9. So we should not change the second largest also. Then here we are going to take 15. Is 15 is greater than 15? No, 15 is not greater than 15. So we will not change our second largest and the largest. Then we need to check again, this 15 is it greater than second largest? Yes, it is greater than second largest element. So we need to change this to is it greater than second largest element, and it should be smaller than our largest element. it is not smaller than our, we should not change over here. Sorry, we should not change over here. We need to check for 25. Is 25 is greater than 15? Yes, 25 is greater than our 15. So we need to change this 9 to our largest element, which is 15, and we need to change our largest to 25. So let us take, we are traversing to the array only once. So from where we have traversed, here we need to take our largest as array of 0 and our second largest as -1. So we are traversing to the array int I is equals to from 1 to I is less than array of array dot length I plus plus. So here we are taking the first element. What we are first checking, whether that element is greater than our largest element. If the element is greater than our largest element, we need to change our second largest element to our largest element. So here we are going to do second largest element as largest element, and then again our largest element will become array of I, or else if suppose here the largest element is greater, for example the element which we are taking is, suppose this element is greater than, let us see, if we are taking 15 and in largest we are having 17, in second largest we are having 9. Suppose it is like this. If you are taking 15 element, is it greater than 17? No, it is not greater than 17. So we will not change either this or this. So we need to check again. Is it 15 is greater than second largest and 15 should be less than largest element. So we will going to change the second largest to 15. Okay, I will explain it again. We need to check whether this 15 is greater than our second largest element. So we, and also the 15 should be less than the largest element. So we can change this to 50. So over here we are going to write whether our element should be greater than the second largest element, and also our element should be less than our largest element. So we can change this to, change the second largest element to array of I, because here in 17 it can be our largest element, here 9 can be our second largest, no, here 15 is there, so it can be our second largest element. So we need to change it by applying these conditions. Here we need to return our second largest element. So here we got our, by traversing through the array only once, we got our solution as second largest element here. So here the time complexity will be O of n and the space complexity will be O of 1. So we have optimized it. Thank you guys.